In this video, we're going to look at another example of using the washer method to compute the volume of a solid. So the question here is to find the volume of the solid obtained by rotating the region bounded by the curves y equals x, y equals 4x, and the line y equals 1 about the x-axis. The first step, as usual, is to find the points of intersection. So we have y equals 1. We plug that into y equals x. And we make y equals y, and we get x equals 1. Plug that into y equals x, and we get y equals 1. So the first point of intersection is x equals 1 and y equals 1. Now let's put y equals 1 into y equals 4x. So we get y equals y. Let's equate the y values, solve for x. 1 equals 4x. Divide by 4, and we get x equals 1/4. And of course, y is equal to 1. So the second intersection point is 1/4 for x and 1 for y. So the intersection points are 1, 1, and 1/4, and 1. These are the intersection points. And they define the region over which we will integrate. So that's why it's important to find the intersection points first. All right, the second step is to sketch the bounded region and a typical washer. So we have all the drawings here, so let's make some sense of these. We have y equals x, that's a straight line going through the origin with slope 1. We get y equals 4x, straight line going through the origin with slope 4. And we have the horizontal line y equals 1, and we're revolving about the x-axis. So notice that when x is between 0 and 1/4, so when x is larger than 0, less than 1/4, the inner radius is x, whereas the outer radius is equal to 4x. But this is very important. When x is between 1 and 1/4, so when the x value passes 1/4, when x is larger than 1/4, the inner radius doesn't change, it's still x. But the outer radius changes. The outer radius is 1. For that reason, we need to do it in 2 stages, and we have to add the 2 results. So looking at the diagram, you can see when x is between 0 and 1/4, the inner radius is x. The outer radius is 4x. But when x is between 1/4 and 1, the inner radius is x, that doesn't change. But the outer radius has changed. The outer radius is 1. So we need 2 separate integrals, then we have to add those 2 integrals. All right, so let's summarize that. When x is between 1/4 and 0, the radius inner is equal to x. Radius outer is equal to 4x. But when x is between 1 and 1/4, the inner radius, that doesn't change, is still x, but the outer radius has changed. The outer radius is equal to 1. All right, so when x is between 1/4 and 0, the cross-sectional area of the washer, A1 of x, is going to be pi times outer radius squared, that's 4x all squared, minus inner radius, which is x squared. But when x is between 1 and 1/4, A2 of x is equal to cross-sectional area is pi times radius outer, which is now different. Radius outer is 1 all squared, minus radius inner, that's the same, minus x all squared. So the volume as a function of x is going to be equal to, actually I should just write volume, because when we compute it, it's going to be just a number. So it's not a function of x after we integrate it. So integrate from 0 to 1/4 a1 of x dx plus integral from 1/4 to 2, 1/4 to 1, sorry, a2 of x dx. And when we compute this, we'll get an answer for the volume, a scalar, a number. So the volume, v of x, no, let me not make that same mistake, sorry about that. Volume is integral from 0 to 1/4. a1 of x is pi times 4x squared, outer radius squared, minus inner radius squared. Integrate with respect to x, plus integral from 1/4 to 1 pi times, the outer radius is not different, is 1, so 1 squared minus x squared dx. Now let me show you the diagram again just so you've seen it. So the outer radius is a distance from the axis of rotation to the farthest point on the slice that you've drawn. So let's consider when x is bigger than 1/4, between 1/4 and 1. You can see the outer radius is this distance from y equals 1 to the x-axis. This is the outer radius. Radius outer is 1, and it's a distance from y equals 1 to y equals 0, which is the x-axis. But the inner radius is the distance from y equals x to y equals 0. So the radius inner is just going to be x. There. So always important to define your inner radius and outer radius properly, because the integration usually is not that hard, but it's just having the right setup that's important. All right, so now let's simplify this and integrate. So we want to set up a definite integral and find the volume. So we've done that. Volume is equal to pi integral from 0 to 1/4, pi integral from 0 to 1/4, and we'll get 16x squared, because we get 4x all squared, 16x squared minus x squared dx plus pi times integral from 1/4 to 1 squared, which is 1, minus x squared dx. All right, simplifying a bit more, we get volume is equal to pi integral 0 to 1/4, 16x squared minus x squared, that's 15x squared dx plus pi integral from 1/4 to 1 minus x squared dx. So let's integrate. Reversing the power rule, we get volume is equal to 15 pi x cubed divided by 3. Reversing the power rule, add 1 to the exponent, divide by the same number. Evaluate from 0 to 1/4. Plus pi times, what is the antiderivative of 1? That's just x. What is the antiderivative of x squared? That's just reversing the power rule, we get x cubed. Add 1 to the exponent, divide by the same number. Evaluate it from 1/4 to 1. Now we apply the fundamental theorem of calculus, put the upper limit in minus the lower limit. So volume is equal to 15 divided by 3, that's just 5. So 5 pi times 1/4 cubed minus, plugging 0 in, that's just going to be 0, plus pi. Put the upper limit, which is 1. We get 1 minus 1 cubed, that's 1 over 3, minus. Put the lower limit in, we get 1/4. Minus 1/4 cubed, that's 1 over 64 times 3 is 192. So there it is, 192. And now we simplify this a bit further. And let's do that on the next page. So we have volume is equal to 5 pi times 1/4 cubed minus 0 plus pi times, let's look at the last page, 1 minus 1/3, that's 2/3. So we have 2/3 minus 1/4 minus 1 over 192. Volume is equal to 1/4 cubed, that's 1 over 64, so we get 5 pi over 64 plus 2 pi over 3 minus pi over 4 minus pi over 192. We take common denominator, which is 192, 192 divided by 64. Let me use the calculator for this. 192 divided by 64. That is 3. 3 times 5, that's 15 pi. Minus 192 divided by 3. That's 64 times 2. 64 times 2, that's 128. So that's plus 128 pi. Minus 192 divided by 4. That's 48. Minus 48 pi. And 192 divided by 192, that's just 1 minus pi. If we simplify this, we get volume is equal to 94 pi divided by 192. If we decimalize this, it's approximately 1.54 units cubed because it's a volume. All right, thanks.